Aditya has told me in all that force is acting. Okay. Once the force is applied, Vidur, once the force is applied, writing, pulling, walking, what are the things happened? Another effect of the force. What is in that all, Vidur? In all that actions, which is common in all that.
Work done.
Work done, the work done we are going to study only, no. Otherwise, what else? See, force applied. When you start writing, you are applying the force. So what happened to your hands? Is it moving or standing? Okay, when you start doing, you are walking. You are applying the force on the feet. So once applied the force, there's an action is done walking. In that, what is that feature? Walking, pushing, pulling. Whenever we do, what is that another quantity common in that? Are you remaining in the same place? Or if you push a chair, is the chair is remaining in the same place? That's my question.
It will move.
It will move. That means in all this action, a motion is there. That means there is a movement. Movement of the objects are there. A movement of you are there. When you write, your hands are moving. So that is what, if force apply, if there is a motion, then we can say it is work done. Or another way, a work is said to be done when you apply a force. There should be a displacement in the direction. There should be a displacement in the direction of force. So that is the definition of the force. That means a work is said to be done when you apply a force. There should be a displacement in the direction of the force. So then we can say it is work done. See, majority of you, some of you, I think I know that. Some of you at home, you are doing some exercise. And especially the boys, you will do some push-ups. Girls also does. Yeah, everyone does the push-ups. Okay, you know the movies and all to get a muscle. Salman, Prabhas, or how much push-ups they do. All this they do push-ups. And in order to increase that muscles in you, 6-pack, 4-pack and all. Usually, where we do, either on the floor, either on the wall. My question is to you, whenever you do push-up, in which direction you act the force? Achyut, in which direction we act the force?
Opposite direction.
Opposite direction? Okay. First, in which? Because suppose you are doing the push-ups. My question is, we are doing push-ups, where you exert the force with your palm?
On the floor.
On the floor. Yeah, you apply the force first, you move forward, then you come backward. So that is push-ups. But my question is, only when you move forward and you apply the force on the floor, there is a motion in the floor? Yeah, because object what you have, it's not your body, it is the floor. You are the source. Yeah, in that case, you are the agent. You can say you are the agent to produce the force. So actually, the force is not exerting on you, you are exerting on the floor. So you are the agent, and when you do exert the force, you are getting an effect. That is what your body muscle becomes strong. But by the way, the force is acting on the floor. Okay, so object is floor. You are the agent. So in that case, there is no motion, there is no displacement, only force is acting. So in that case, we can say there is no work done. Because you are acting force, but there is no movement of the wall. If you push a wall, forget about push-ups, you just push a wall. You push a very huge stone. It is not moving. That means ma'am, I exert a lot of force. I am starting sweating. But still, where is the displacement? So in that case, we can say no work is done. So that means displacement is an important identity or physical quantity which tells you whether you are doing work or not. Okay, scientifically, whether you are doing work or not. And this work done can be 3 times: positive work done, negative work done, and zero work done. Okay, so let us see. The definition of the force and as well as that. So any work, any profession, we have the force acting on it. Clear? So we are coming to the definition of the force. A work is said to be done when force acts on an object and the object is displaced in the direction of the force. Now, thus, we can measure the force as the product of force and displacement. We can measure the work done as the product of force and displacement. And in your book, sometimes we use, instead of S, we can use D also. Okay, D also indicate the displacement. So, the measurement of work done is force into displacement. I think you have studied in 9th standard chapter work, energy and power. And what is the SI unit? Joule. That also we have studied. So first 2-3 pages are only revising what you have studied in 9th standard. Okay. Then afterwards we are moving on to two-dimensional work done energy. That is this chapter all about. Everything we are discussing in terms of two-dimensional, one-dimensional motion. So the standard equation is F into S. So 1 unit of work is joule. And how can you define 1 joule of work? How can you define 1 joule of work? So we can define 1 joule of work is, it is the amount of work done when a force of 1 Newton displaces an object by 1 meter. So how could you define? 1 joule is the amount of work done when a force of 1 Newton displaces an object by 1 meter. The first sentences which is in the box, that is only the meaning of this. That is, force is 1 Newton, displacement is 1 meter, then work done is 1 joule, or unit of force is Newton, unit of displacement is meter. So you are getting Newton meter. Okay, so 1 Newton meter also can be equal to 1 joule. So there are two equations in this case, 1 Newton meter and 1 joule. So 2 Newton meter means 2 joule. 100 Newton meter means 100 joule. Okay, so there's a balance. So what is 1 joule? It is the amount of work done when a force of Newton displaces an object by 1 meter. Clear, students? So that is about it. So for an example, I am giving a problem here. It's a simple problem. You don't have to copy, just write. For example, F is 5 Newton. You can just write a short form. For example, F is 5 Newton and displacement is 2 meter. Therefore, work done is equal to Fs 5 into 2. It's clear. It's given in the thing 10 Newton meter or joule. So that's a symbol. Maybe one objective type questions like that. This is what we study 9th standard. Okay. That's about work done. Shall we go the next one? Now we are going to identify different types of work. That is, a work can be positive, negative, and zero. That is the types of work done. Yes. We come back to the diagram after learning what do you mean by positive work done, what do you mean by negative work done. Okay. So work done may be positive or negative or zero. It can be also or zero. And when it will be force is positive, if the force and displacement are in the same direction. If the force and displacement are in the same direction, we can say it is positive work done. Positive work done. Another thing, when can we say the force is negative? Work done by a force is negative if the force and displacement are in opposite direction. So this is one rare case. Every time it won't act opposite direction. It's a rare case, of course. If you say push-ups, if you do the push-ups, the upward motion of your body after exerting the force, as Punya said, it will be in opposite direction. We can say that is negative work done. Pushing ups your body. So in that case, what we do means there is a normal reaction forces exerted by the floor in order to raise your body up. Then only we can say there is a work done. Otherwise, we don't say no work done. Okay. If you think about, consider the displacement of the floor and the person, then no work done. But if you consider when a person is pushing the floor, there's a normal reaction force against that. Yeah. That is making you to rise upward. Then that is giving an effect on your body to become strong. So in that case, we can say it is a negative work done. Only that part, pushing up, pushing down, no work done. That is how. Similarly, another example in our daily life is gravitational force. Whenever an object is climbing upward, the force, gravitational force, pushing you or pulling you downwards, acting in the direct opposite towards the center. So that is a negative work done. Person is moving up, but force is acting downward. So this is an example for negative work done. Another example, bouncing of the ball. Yeah. If your rubber ball is bouncing after hitting on the wall or the floor, a ball is bouncing back. Then we can say it is a negative work done. So these are the some rare cases we can say work is negative. So negative means it is not the value is negative, only direction. Direction. When you say positive, it is only indicating direction. That's the one. Clear? But even work is the product of two vectors, force and displacement. Then also we call it work is a scalar. That's another peculiar feature of work. Work is the product of two vectors, actually, F cross S. But in this case, it is a scalar product. More than F cross S, what we do, we apply Fs actually is equal to F dot S. It is not F cross S, F dot S. So it is a scalar product. It is a scalar product. That is what we are telling. Work is a scalar. It is not F cross S. If it is F cross S, it can be a perpendicular or it is a vector product. But even F and S are vector quantities, it is a scalar product F dot S. So, suppose an object is acting at an angle, then work done is equal to F dot S or Fs cos theta. Suppose an object is acting a force at an angle. So that means displacement and the force in an angle. Not 90 degree at all, an angle. In that case, we can say work done is equal to F dot S. It is equal to Fs cos theta. Whichever is the theta, we have to consider whether 60 degree or 30 degree or 15 degree or 50. So that is Fs cos theta. Clear? Yes. So I think it's clear to you. If an angle, the work done, we change the same equation into a dot product or a scalar product. So it is Fs cos theta. Then third type work done is it's a zero work done, no work done. That means no work done can be two cases. One case, only force, no displacement at all. Only force is acting, no displacement at all. Okay. Now you all are sitting on a chair. Yes, you are exerting force on the chair, but there is no displacement to you. So no work done on your body. If you are writing, only that part is work done. But now you're simply sitting on the chair. You know it. Gravitational force is pulling you. And normal reaction force is in opposite, equal and opposite on your body. No work done. There is no displacement of your body. So you are zero work done. Clear? And apart from this, another peculiar feature is work done by be zero if force and displacement is perpendicular to one another, 90-degree. This is why we don't use cross product, because when F and S is perpendicular to 90-degree, also no work done. No work done. If you say yes, a constant work is done, but the problem is there is no displacement. Displacement and force is in at a 90-degree. So it is a second case where work is not done. One is no displacement. Another one is if force and displacement is perpendicular to each other. Then we can say there is no work done. So another example for this is planets revolving around the sun. Planets revolving around the sun. Planets revolving around the sun. Suppose this is our sun, and if a planet's earth is rotating, look at the motion of the earth. Earth is at a tangent to the circle, so that means it's a straight line motion. But where is the force making them to rotate? It is the gravitational force. It is a gravitational force between the displacement and between the earth and the sun. So in this case, forcing acting towards the center, but object, if you draw the tangent, at every part of the tangent, if you draw, the earth is rotating in a straight line, we can say. It is a constant motion. So in a constant motion, we cannot say there is a work is done. Constant motion. That means there is no change in velocity. There is no any unbalanced force is acting. That is a time we can say work is done constant with a steady. Okay, so this is an example for no work done. Electrons are revolving around the nucleus. Electrons are revolving around the nucleus. No work done. Because the force between nucleus and electron is towards the center, but the movement of electron is tangent to the circle or tangent to the orbit. So that's the reason. Okay. So let us now go back to the diagrams. Next heading, work done by a constant force. So this is now plus one portion. So far, what are the things we studied is revision of your 9th standard. Now, in this chapter, we have to study work done by a constant force, work done by a variable force. Work done by a constant force, work done by a variable force. So first we discuss work done by a constant force. Of course, since the two-dimensional motion, if we consider there is a theta is coming to play. Then we use the equation Fs cos theta or Fd cos theta. Both ways you can represent. That means F dot S, F dot D. So let us look at the lady. That lady, she is carrying the suitcase, luggage with the trolley, holding the trolley or holding the luggage at a particular angle. And you can see that she is moving with the constant force. There is no change in her holding the luggage and all. So yes, in this case, she is doing a work. In this case, she is doing a work. It may be 30-degree or 40-degree or 60-degree. It depends upon it. So when you find out the problem, suppose it is 40-degree, you have to write Fs cos 40-degree. So how much force, how much is the displacement? Suppose this is around 1 meter. Then suppose it is around you can say, maybe she applied 5 Newton. Then if this angle is 30-degree, suppose this angle is 30-degree, your answer should be work done is equal to 5 into 1 into. What is cos 30? Come to the thing. Cos 30, children. Whom I can ask?
Root 3 by 2.
Huh?
Root 3 by 2.
Root 3 by 2. So we have to apply that. And then you have to find out. Okay. 5 into 5 by 2, that is 2.5 root 3. 2.5 root 3. Okay. Suppose if you are using logarithmic table, you have to find out root 3. In square root and all, we can find out odd numbers 3, 5, 7. All this square root you can find out from the Clark's table. Okay. So that is the one. Okay, children. Now, suppose if this lady holding her luggage perpendicular in this way, then that is the time 90 degree. Yes, she is walking, but the problem is she is holding the luggage perpendicular. She is walking another direction. It becomes 90 degree. In that case, the answer going to be 0 because cos 90 is 0. Okay. So, as a +1 and +2, you have to learn what's the value of cos 0. Usually it comes in the work done. Cos 0, cos 90, cos 0 is 1, cos 90 0. Similarly, sin 90 1. So we don't want sin because our equation only wanted cos. Okay. Then cos 180 degree minus 1. Okay. So cos 0 1. It comes when force and displacement in the same direction because it is not making any angle. Correct? Just like this. Yes, just like this truck. You just think about the truck here. A truck is moving and a load is kept on the truck. Okay. And if you just consider the motion of the truck, they are the angle between the truck and the surface. They are in the same. The force applied by the truck and everything, displacement, everything in the same direction. This is a condition cos 0, 1. They are parallel. So that is why cos 0, 1. Similarly, if you just consider free body diagram of this load, which is also going to be a straight line. Okay, displacement and as well as. But in this case, what is happening here? It's a negative work done because force is acting on the object this way, but gravitational force is acting in this way. Okay, so that is about the cos parallel connection. Similarly, let us go back to the lifter. Some example what we see in a daily life. Weight lifter. Okay. Weight lifter, just look at the angle. Usually weight lifter, what he does? First, the weight should be on his body. Okay. At that time, cos 0, no angle. Then when he raised up, what is happening? He is raising upward, but gravitational force is pulling this weight downward. So that is why it become cos 180. So these are the some cases work can be negative when you consider the angle 180 degree. Okay, children? Yes. So I hope you understood negative work done and work done by a constant force. And these are some peculiar features of one, that is work is a scalar. Same thing, work can be positive, negative, or all those things. And I think next we have to study, and these are all for you to understand some examples. How does the work act? Okay. So just observe all these diagrams and you yourself have a analyzing the pictures and identify which is the work done, which is not work done, which is negative work done. Clear? Yeah. So we can do some problem used on this, and afterwards next class we will study work done by a variable force. Okay. So just observe the diagrams and then we will do one problem based on it. Okay. Okay, children, shall I change it? And this is also an example of negative work done. I explained to you. Yeah. So just to observe that. A ladder, a person is climbing upwards. And another peculiar feature means when a person is going upwards, instead of Fs cos theta, what is the force acting here? If you just forget about the theta, if you just take it, work done is equal to Fs. F stands for weight of the person. Whenever an object is going upwards, you already know that the gravitational force pulling. Can you tell me the instead of F, what can we write? Can you tell me, Emmanuel? Video off. See, once I stop sharing, I can see majority your videos are off. Yes.
G, ma'am.
Ah. F is equal to what, Emmanuel?
G.
Mg. Yes. So then our equation is going to change. Instead of work done, we are going to learn another equation. Work done is equal to mg. Instead of s, we can do mgh. So three equation: work done fs, work done mgh, and another work done is fs cos theta. So depending upon the situation, we can do the problem. Okay. So if you want, you can copy as an example this question. How much work against gravity would a 50 kg person do if he climbs a flight of stairs 3 meters high? Just copy this question. How much work, first question, how much work against gravity would a 50 kg person do if he climbs a flight of stairs 3 meters high? And just I give you, flight means there's a lot of stairs are there. I just give you a number of the steps in that for you to make it easy. He is climbing 20 steps. 20 steps, each step has 3 meters. So in bracket you can write 20 steps. So this is flight means there's a lot of stairs are here. Okay. So we don't do that because it's a part of variable force. At present, we will do a constant force. Okay. So we can write in bracket 20 steps for one staircase and each step has 3 meters. Each step has 3 meters. So can you tell me what is going to be answer? Forget about these variable forces. We can just do our own. MGH. First,
50
work.
into
What is the mass? 50
kg
then
into 9.8,
into height.
20 into 3.
Correct. 20 into 3 because each step has 3. So there are 20 steps. So height is going to be 20 into 3. Yes, tell me the answer.
Uh, 2940 joule.
2940 joule. Did you all get, children? After removing the decimal, you will get 294 joule. Okay. So remaining we will discuss in.
Is it correct? Is it correct?
Let me check. 5 into 2, 5 into 2, 100, 100 into 3. You will get 300. No, yeah. 300 into 9.8. Just multiply 98 into 3. You will get that. Then after you add the zeros. Have you all got the answer?
Yes,
98 into
ma'am.
3. 98 into 3, 8 threes are 24. 9 threes are 9 threes are 27. 27 plus 2. Just check here. Are you getting the correct answer? Some changes now? Okay. So, ma'am, sir is waiting. So, we'll continue the next class. Okay.